Okay, this is my separations midterm. So for number one, V over F equals one, which is at the dew point, therefore Q equals zero, and Z of F equals 0.45. Part that I got wrong, V over F equals one because to get to the purest liquid stream, it needs to occur at the highest vaporization point. I did two correctly, but just to go through it again, a stripping column with a partially boiler is used to separate a binary mixture. The objective is to maximize the purity of the bottoms, and the distillate is removed as a saturated vapor. The plant manager wants you to decrease the total number of trays in the column to maintain the same separation performance as before. How should you modify the boil-up ratio? You should increase this that parameter, sorry, increasing the blood ratio creates a better separation, allowing for fewer trays to do the same amount of work as a column with more trays and less vapor. For three, the only part I got wrong was this part. Let's just go through the whole thing again. The pressure in the can headspace decreases. The dissolved CO2 concentration is now above the new equilibrium solubility predicted by Henry's law. So CO2 leaves the beer. A warm 76 degrees Fahrenheit can of the same non-alcoholic beer would foam less vigorously during shock coming because the solubility of CO2 decreases with increasing temperature. I got this part wrong because CO2 dissolves better in colder liquids, and CO2 is less soluble in warm liquids, so it would decrease, not increase. For four, I got four correct. X3 is 0.27 and Y3 is 0.65. So in that graph. I also got five correct, but just to go through it again, 10 plus PR plus PC. And the equilibrium stage is 10, and then solving for the efficiency that is an EQ over an actual, which is 0.14, it gives us that overall efficiency. And then we can rearrange that and solve for the actual, which is 25 stages. Six, I did get six wrong. It's only A, not D as well. A is not physically possible because the feed is less pure than XB. XB cannot be greater than X of F. B is fine, just totally equals bowl. C is just normal. D has a really high reflux ratio, which makes it look kind of weird, but it's technically fine. And then for seven, what I got was this X of 4. Here, we're reading this value this way, this number, not that way. Yay, me. But slope of the feed is Q over Q minus 1, and you plug and for that, and equals 6, and then Q ends up being 1.2. And then for B, we're looking for the referring train with the efficiency of S4, and that equation is x of n minus x of n minus 1 all over x n star minus x n minus 1. Then you can plug those values in, and you can find them up here. X4 star is here. That's what you're looking for then. And then you plug both of those in. And then you get 28. So it's efficiency. And for 8, we're determining Q and plotting the feed line. So Q equals 0 minus 1/3. That means Q just is 1/3. And then you plot the feed line with this equation from the sheet. It is 1 over 4x plus 0.4875. Plotting that. This line here is the feed line. And then the pinch point is here. Which is also stated here. And R min over R min plus 1 equals this guy. And then that equals 0.61. And you can use that number to solve for R min. So 0.61 all over 1 minus 0.61 is 1.566. And then you can use that to solve for actual R, which is just 3 times R min, which is 4.469. And then for part C, we're solving for toll and bowl. And then this is the equation you get for toll using the equation from the equation sheet, 0.824x plus 0.167. Then you can solve for Q, which is still negative 1/3. And then you can solve for L hat, or right over that, for the bottoms. But that's just 264.61. And then for bowl, you're solving for this, you solve for the slope first, which is U plus 1 over U. and you plug that in, you get 1.13, and then you solve for U, and you can solve for V hat, V for 7.59. And then using the equation F plus L plus V hat equals L hat plus V, you can solve for V, which has I'm going to use 380.93. And then because F equals D plus B, and then using 0.65 F equals 0.95 D plus 0.055 B, you can solve for D and B. And then R equals L or D, and therefore you can solve for L. And so those are numbers that you need down here. But in this Q is from part A. But to solve for n total and n feed optimal, you can plot the total in the bool line that you solved earlier, and then just draw out all of your stages. And I got 7 stages plus partial reboiler, and then my optimal feed stage is stage 4. And then for 9, we're gonna find T2 and Y2 first because we have the liquid product composition is 3% methanol, which you can just pull off here, and you can just pull those straight off the table. And then you have to look for some minimal balances to get the other one. But for the flashing one, F1 equals L1 plus V1, and then so V1 equals 10 minus L. And then you also have this equation, and you also can pull from the equation sheet. But you have, looking at flash 2, you have F2 equals V2 plus L2, and then you can have 1 equals V2 over F2 plus L2 over F2. And then L2 over F2 is 0.75. And then pulling this equation down, also using it, but just for flashing 2. You can solve for x of 1, which is 0.398. And then using this x1 value, you can take that from this table. And then you get T1 equals 75.3 degrees Celsius and Y1 equals 0.729. That's part A. And to find the flow rates of vapor and liquid out of the first flash drum, just look at F1Z1 equals L1X1 plus V1Y1. And then that's just the same thing. And you have, sorry, you can also use the equation F1 L1 plus V1. Just using those two equations, you can just plug in 10 times 5.7 equals 0.4 L1 plus 0.729 V1. And using those two equations, two unknowns, L1 and V1, and you can solve for L1 and V1 from there. So you have 483 moles per second for L1, and for V1, you have 505.17 moles per second. And that's essentially everything tabulated down. So thank you.